Let's find the solution to the given linear inequality. It's an inequality because we have an inequality sign involved in, and also linear because the highest degree of x here is 1. Let's begin. So first step, what we'll do, we will distribute half with the two terms within the parentheses. So we have 3 divided by 10 times x plus half of 4. So that's going to be 2. So this is greater than or equals to 1/3 of x minus 1/3 of 6 will be 2. Fine. In the next step, let's transpose 2 from the left hand side to the right hand side. All we have to do is subtract 2 from both sides. So we have 3/10x. But this will be greater than or equals to 1/3 of x. We have -2, -2. So we have 3/10x. So this is greater than or equals to 1/3 of x minus 4. Now we will transpose 1/3 of x from the right hand side to the left hand side. So we'll have 3/10x minus 1/3 of x. So this is greater than or equals to -4. So let's combine the two terms on the left hand side. So the least common multiple of 10 and 3, that was going to be 30. So in the numerator we have 3x, so this will become 9x minus, in the denominator we have 3. So this means in the numerator we'll have -10x. So this is greater than or equals to -4. Now what we'll do, we'll multiply both sides with positive 30. So we have to be very careful when we are multiplying with any numbers, since our number is going to be positive 30. So there is no change in the inequality sign. So we will get, so the 30 and 30 goes away. So we have 9x minus 10x. So 9 minus 10x, so that's simply -x. So this is greater than or equals to -4 times 30 will be 120. Now we'll be multiplying both sides with -1. So this time we have to be extremely careful. So whenever we are multiplying with -1, what happens is that the sign of the inequality, so this changes. So this changes to less than or equals to. That means we will have x is less than or equals to positive 120. So this is going to be the solution to a linear inequality. So if we want to represent a solution in a graphical way, so that means we'll consider a number line. Here on the number line, we'll consider the point 0 and 120. On the extreme left, we have -infinity, and on to the extreme right, we have positive infinity. Our solution is going to begin from -infinity and go all the way up to 120. That means all the values less than 120 are going to be the solution to this given linear inequality. And 120 is also included, so that means we'll consider a dot here which represents that 120 is also a part of the solution. And the third way is writing our solution in an interval form. The interval form means it starts from -infinity and goes all the way up to 120. So here -infinity is unbounded, so we'll have to use an open interval, but 120, this is included in our solution, so that means we will use a closed interval. So this is in a semi-closed interval form. So these are the 3 ways of representing the solution. And if you want to check out if these are true solutions or not, you can take any values of x less than 120. Or let's say if we take x equals to 0, and if we plug this value into our equation, so let's do that as well. So we are half of 3/5x, so this will go to 0. So we have half of 4. So we have half of 4. We are saying that this is greater than or equals to 1/3 of 0 minus 6. The 1/3 of 0 minus 6, that's -6. So we have 2, which is greater than or equals to -2. This is true. So that means any values of x less than 120 is going to satisfy this given linear inequality.